Okay, this is for Year 11 methods and it's concerning graphing exponential functions out of 8.4, and I'm going to do a couple of examples. Okay, the first one's 8.41d, graph y equals 4 to the 2x minus 4. Okay, so it's an exponential base 4. All exponentials have the same pattern that look like this and have a y-intercept of 1 unless there's translations, transformations, dilations or reflections. In this particular case we have a dilation and we have a sideways movement. That's not going to affect, because if I move sideways it's not going to affect where the asymptote is. So I'm still going to have my asymptote at y equals 0. And it's going to be stretched and it's going to be moved sideways, but the graph is essentially still going to have the same shape to it, like this. However, I'd like to work out 2 points. I need axial intercepts, so I need to find out where the y-intercept is. That will always occur when x equals 0. So y when x equals 0 will be 4 to the 0 minus 4 or 4 to the minus 4. I'm going to use index notation 0, 4 to the minus 4 to show the y-intercept. I like to choose another point. The other point that I'll choose is when x equals to 1. So y of 1 equals 4 to the 2 minus 4 or 4 to the minus 2. So there's my second point at 1, and 4 to the minus 2 is 1 on 16. There's my graph of that first one, which is 1D. Looking at 8.42D, this is the graph that I'm drawing. Base 3e to the x plus 2, keeping in mind that my original would look like this going through there at 1 and having an asymptote there. I've got no dilations, I've been moved up to, so this whole graph has been moved up to, therefore I'm going to have my horizontal asymptote here at y equals 2, and the curve is going to look like this, having an exponential pattern to it. It's going to go through there when that's when x equals 0, y of 0 will equal 3 to the 0 plus 2, 1 plus 2 or 3. So that goes through there at 3. I need a second point when x equals to 1. Y of 1 will equal 3 plus 2 or 5. So there's my second point at 5. Y, x. Beautiful. I've labelled my asymptote, I've put its equation, I've labelled 2 points, I've labelled axial intercepts. 3b, y equals base 5 e to the minus x. I know normal exponential would look like this going through at 1 and having an asymptote there at y equals 0. The only transformation is this negative on the x. Since x has turned into negative x, it's a reflection over the y-axis. So we have this flipping occurring around the y-axis. It's a flip like that. It's flipped around over the y-axis. So what's my graph going to look like? It's going to go through there at 1 as normal. It's going to have an asymptote there at y equals 0, and it's going to look like that. I've got 1 point labelled, I need a second point labelled. I'll choose x equals to 1, y of 1 will equal 5 to the minus 1, or coordinate there of 1 and 1/5. That's x, that's y. It's beautiful. 8.4 question 4. Y equals negative 5 to the power of x. It's an exponential base 5. Normally it would look like this, going through at 1, having an asymptote over here. The negative at the front is a reflection over the x-axis. Therefore it's going to flip over the x-axis. That's not going to affect where my asymptote is, so I'm still going to have an asymptote at y equals 0. However, my graph is going to look like this, where that now goes through at -1 because it's been reflected over the x-axis. There's y, there's x. I'd like to have another point. I'll choose the point when x equals to 1. Y of 1 will equal -5 to the 1 or -5. 1 and -5 is my second point. I have 2 points labelled, I have all the axial intercepts labelled, I have the asymptote labelled. Beautiful graph. And the last question in this set involves a couple of transformations. What I've actually got here is y equals 5 minus x minus 3 plus 1. I'm going to separate the reflection from the transformation or the translation. So what's actually happening here is I have a reflection over the y-axis. Therefore it's going to flip that way and that way over the y-axis. It's been translated right 3 and up 1. This is the translation to the right 3. This is the translation up 1. This reflection will not affect where the asymptote is. This translation will not affect where the asymptote is. This translation up 1 will affect where the asymptote is. So I'm going to draw my axis, and my asymptote is now going to be at y equals 1. This is the only thing that affects where the asymptote goes. The negative will reflect it over the y-axis. So instead of going this way, it's actually going to go that way, and I've moved to the right 3, so the general shape will still be like this. However, I don't know where it's going to touch here because I've had some form of translation to the right. I could work it out though. Y of 0 will give me my y-intercept. So 5 to the 3 plus 1, 125 plus 1, 126 is going to be my y-intercept. And I need a second point, so I'm going to choose when x equals to 1. Y of 1 will equal 5 to the 3 minus 1 plus 1, 5 squared plus 1, 26. So that coordinate is 1 and 26. That coordinate is 0 and 26. That's the y-axis, that's the x-axis. The asymptote's labelled. Beautiful graph. 3 ticks and a smiley face.